Hey guys, my name is Michael Cho from FrodoBots. Today I would like to share with you the open source release of a dataset. We're calling it FrodoBots 2K dataset. Me and the team have been working on this for the longest time, so we are super excited to be able to finally share this with you. So what is this dataset about? So this is basically an urban navigation dataset, and it consists of something like 2,000 hours of teleoperated sidewalk robots that are being driven in more than 10 cities. And it's being released under Creative Commons BYSA 4.0 license. So effectively, you can even use this dataset for commercial use in case that's what you are thinking about. So how do we collect this dataset? So let me just show you a video. So actually, we have been building this game called as you can see, we term it as a drive to earn game. And the idea is that as you drive this sidewalk robot, you earn in-game points. And in a way, while the gamers are playing the game, we collect the data. So the longer you drive, the more points we give you. And also, the more difficult the drive, the higher points you will get from the game. These sidewalk robots are all 4G enabled, and you can control it with a game controller, wheel control, or keyboard. The robots also come with speaker and microphone, so the gamers can actually talk to people around the robot. There's a headlight in the bots as well, so we've done plenty of night drives. And as you can see, this robot has been tested in different environments, and like I said, more than 10 cities now that we've been testing this in. So the experience is very much like we usually like to call it. It's like playing Mario Kart, but you do this in real life. So that's the game. And if you come to the, so we have a school, we call it the Rover school. So the idea of the school is that this is for new gamers who are not prepared to buy the hardware yet. All right, so they can actually just dial into the game and they can start to, after a test drive or tutorial, they can actually start to play some of these robots that will be placed in different cities around the world. But the main thing we actually focus on, we actually have just started selling the robots. So the robot that you saw just now, we're starting to sell them for $300 US. And the idea is that you can buy it and then you start driving around your neighborhood. And as you drive, again, the longer distance you drive and the more difficult you drive, the more points you earn. Let's dive into the dataset a little bit more. So this is a distribution of the driving session duration versus the total duration that we've been recorded. So from here, you can see roughly, most of these driving session, which means one driving session, you can think of it just as a continuous drive. Yeah, most of them usually last for about, say, 10 minutes, 15 minutes, something like that, right? Although some of our drives are pretty long, it can be more than an hour. So this is how, it kind of stack up. So most of these drives are actually not super long. As a continuous drive. This is how the data is being spread out across the cities. So in fact, we have way more than 10 cities now. It's probably more than 20 cities already. But as you can see, most of these cities are still pretty low number of hours. That's because a lot of these are just very recently deployed in the cities. So hopefully during our next release, a lot of these cities, the number of hours will come up. Yeah. Now, and we do actually provide a kind of a helper script. So if you go there, there will be some sample code. But essentially, if you look at each of these driving session, or we call it basically a ride, there are different data that you'll be given. So there's the control data, right? So this is basically what the human, or rather what the gamer is doing, right, on his game controller. There's also revolutions per minute kind of data for each of the motors, right? So over here, and all these are going to be timestamped, right? You have GPS data, you have 9 degree of freedom IMU, you have, of course, the front camera and the back camera as well. Those are actually typically recorded at about 20 frames per second. And like I said, there's microphone and speaker as well. So, and if you download the dataset, there will be many rides, and in each of the rides, this is kind of the file structure. The thing I wanted to highlight is that in each of the rides, there's another subfolder called recordings, and if you go into it, you'll find a bunch of TS files as well as M3U8. So these are the main video and audio files. And I would say if you want very accurate timestamp with to the specific video frame, that's where you get it. Anyway, we will have some examples on how to do that in our helper script. So You can go and take a look. Now, I do want to spend a few minutes to talk about latency, right? So, because these robots are all basically teleoperated remotely, and oftentimes actually halfway across the world, right? The gamers could be, in this case, for example, like the gamer could be sitting in Tokyo, and the robot could be in one of our cities, right? Let's say Madrid. And all the streams are actually, all the data, video and control data are actually going through the WebRTC stack. So let's say the server in Singapore, right, as an illustration. So let's go through a cycle, right, an action cycle. So let's say we first start with the robot, right, which is red, right? So the robot, again, is in Madrid. The robot captures a video frame. And this video frame is now being sent to the WebRTC server, like let's say all the way to Singapore. And our estimate is it can take up to maybe about like 200 milliseconds, right? Something like that. And then from the server, it would then, route it to the actual, the gamer, right? So in this case, the gamer is in Tokyo. So this whole trip, it's already close to half a second. Now, this from this leg to the gamer, actually, there's a little bit more time because it does takes a while. You can imagine, depending on the browser and the computer that the gamer have, it does take a while to to render the frames. You can imagine. So now, and of course, then once the gamers see the video frame, the gamer will decide, okay, should I go straight or should I turn left or turn right? Right. So there is some human reaction time. We don't know exactly what's a human reaction time, but there will be something. But then imagine once the gamer decided that, okay, I need to turn left, that control signal is then now being sent back to the WebRTC server, because again, the data is actually going through WebRTC as well. And then finally from the server, it goes to the robot, right? So if you look at this whole like so-called cycle, from the human gamer's perspective, right? So what you will feel as a gamer is, from the latency you will feel is from the moment you send out the control data to the moment you see, let's say, turn left and you finally see the video turning left, right? Or the robot turning left visually through the camera. So it will often feel like it's about half a second kind of latency. So there is latency, and everyone will feel it. But from our experience, usually it takes, even if it's someone who is not a hardcore gamer, it usually takes just a few minutes for the gamers to get used to this kind of latency. The other thing to note is that actually these robots don't travel that fast. The maximum speed is something like 3 kilometers per hour. So actually pretty slow. And also because the camera is kind of close to the ground, it's got wide angle, so it doesn't feel that slow, honestly. The driving experience is actually still quite exciting. But I just want to highlight that there's this latency, right? So the question is, like, when you look at a timestamp in our data set, the question is, what does that timestamp actually mean? Because if you look at this whole thing, there are actually 3 clocks here, right? There is the clock at the gamer's browser. There is the clock in the, let's say, the server, the WebRTC server, and then finally there's a clock in the physical robot, right? So right now, when we give you a timestamp for the human control data, actually that control data is recorded at the robot. And so you can actually see there's already, in a way, maybe up to 100 millisecond kind of like latency. So this timestamp could have been actually 100 millisecond after what the gamer actually do, right? And in fact, in terms of the video, right, the front camera, the back camera timestamp, right now the videos are being recorded in a cloud. So and as you can see, it's another maybe like 200 to 300 millisecond from the moment that actually the human gamer sent through the control. So while you look at the timestamp, do keep in mind that actually there are all these latency issues that is not constant, right? This is just our best guesstimate. Honestly, things will change. Sometimes it feels a lot faster. Sometimes when it's bad, it can be quite bad, right? And so, but what I want to say, like I said just now, is despite all this latency issue, and sometimes it's not super consistent latency as well, human beings or human gamers, especially the experienced gamers, are able to overcome most of this usually, and still able to complete the missions in real life. Maybe one other thing I should add is that I think, the ideal case maybe perhaps is you want to record the timestamp from the perspective of what the humans see. So in theory, we should have, let's say record the control data directly in the gamer's browser, and also, the video frame directly only when it's rendered in the gamer's browser. The issue with that is actually an engineering issue, right? So obviously everyone's laptop or desktop that these gamers use are completely different, right? So it's very hard. You can imagine if someone opened up a Chrome and it's got 100 tabs open, we don't have very good guarantees on the kind of performance that we can get out from the gamer's browser. So for now, the decision with now is this is where we actually timestamp the data. So maybe in the future, we will try to make better engineering. Maybe we can figure out how to record things directly on the gamer's browser. But for now, this is what we are doing. Maybe as a last thing to say, this is our first time doing this kind of open source data. We are not researchers. We are not data scientists. None of us on the team are. But what we focus a lot on is just creating a fun gaming experience for these gamers. But like I said, as the gamers play the game, actually they do create, I think, very useful teleoperation data that hopefully can be very useful for advancing basically embodied AI research. Be it the data set, but also I think hopefully with the global fleet of robots that we're going to build up over time, perhaps some of you researchers, maybe you build very cool autonomous navigation models that you want to actually deploy in the real world and test across many cities. Do come and reach out to us. We would love to see how we can help. But on the other side, we do need a lot of help. Like I said, we are not expert in actually pretty much all these things. Honestly, we have way more data than what we actually have released now. So if you want to help out, in terms of data cleaning, analytics, annotations, visualization, anonymization, and that's something actually we are working quite earnestly on, face blurring and all that. So yeah, I mean, we do need help, and hopefully, if you think what we're doing is interesting and could be helpful to the research community, we are asking for your help, right? So do reach out, join our Discord, and jump in and discuss. And you can easily, direct message me on Twitter as well. So anyway, thank you so much for listening, and hopefully you enjoy this data set. Cheers.